Let's take a look at the volume of pyramids and cones. Now, how can we find the volume of a pyramid? Well, here we have a pyramid here. Let's construct a cube around this. Okay, something like this. Now, we'll just put one more down here. Okay, so now we have a pyramid at the base of this cube. Now, how many pyramids could we fit into this cube? Well, first of all, let's say that here we have the height, the perpendicular height of this pyramid. Let's say that this cube is twice that height, and therefore 2h is the dimensions there. What would be the volume of this cube? Well, the cube is simply cubed, the length cubed. So the volume here is 2h cubed, got units cubed, and that becomes 8h cubed is going to be the volume of that cube. Now, ask yourself, how many pyramids could fit into the volume of this cube? Well, if we've got one at the bottom, one at the top, one at the left, right, front and back, you could fit 6 neatly into this cube. So therefore, the volume of a pyramid is simply 1/6 of this cube. One-sixth times that there, 8h3. Okay. So let's what's that equal? Well, if you wrote it like this, that simplifies as 1/3 times 4h cubed, and then what you'll see is that you can pull a height out. So why are we doing this? Well, let's have a look at what the area of this the base of this pyramid is. So area of the base, well, in this case it's 2h by 2h, which means it's 4h squared, which just happens to be this part. So we can write our formula for a pyramid like so. Volume is equal to 1/3 times the perpendicular height times the area of the base. And there you have it. That's the formula for not only a pyramid, but this works also for cones or triangular pyramids. So let's have a look at how we might solve a problem here. Let's okay, let's say we've got a cone. Now, sometimes they'll give you the perpendicular height, and sometimes they won't. So let's just put in some dimensions here. We'll say that that can be 12, and we'll call the slanty height here 20. Well, in order to solve this problem, we're going to need the perpendicular height. Okay, so that's this part here. Now, we can do that in this case using Pythagoras. Now, if this side is C and this is A, we'll just call it H here, A and B, then you should be getting used to writing Pythagoras in a rearranged form. C squared is A squared plus B squared, and so this is going to be 20 squared equals, we'll call AH, okay, H squared plus, and what's this dimension here? It's going to be 6, 6 squared. So if we write it like this, 20 squared minus 6 squared, you can see where that comes from. Well, that's 400, take away 36, which is 3, 60, I think. Let's leave that in exact form for now. So that's going to be our height. Let's leave that in exact form now, and we can use this now to find the volume. Let's find the area of the base now. It's a circle. What's the radius here? Well, it's the same as in that triangle, r squared. So pi 6 squared is 36 pi units squared. Okay. So we can use this now together with our height to find the volume. 1/3 times the perpendicular height times area. Just remind you that it's a base. Okay, so 1/3 times, here we go. So we can put it in exact form here, and then round at the end. Well, let's see what this comes to. Right, so that's 720.2405. Let's round that to one decimal place. 720.2, and this is units cubed because we're talking about volume. Put that in there, just to one decimal place. And there you have it, your formula and method for finding the volume of a pyramid or a cone.